Stanford problem 14, observe that 1 is equal to 1, 1 minus 4 is equal to minus into bracket 1 plus 2, 1 minus 4 plus 9 is equal to 1 plus 2 plus 3, 1 minus 4 plus 9 minus 16 equal to minus into bracket 1 plus 2 plus 3 plus 4. Guess the general law suggested by these examples, express it in a suitable mathematical notation and prove it. This is the problem given in the Stanford Problem 14. Now we will answer this problem as a solution for this problem. Let us consider the above pattern, above example given in the form of a table. Consider, consider 1 equal to 1, which I can write down, 1 equal to, as given in the problem, that is minus 1 plus 2 and 1 minus 4 plus 9 equal to plus 1. 1 plus 2 plus 3, and the fourth line, which you can write down, 1 minus 4 plus 9 minus 16 equal to minus into bracket 1 plus 2 plus 3 plus 4. Now in the first row, second row, third row, fourth row, observe these rows and you can see here we can write the above and write the above table in the following pattern. Now I can write down this 1 as minus 1 raised to 0 into 1, and 1 minus 1 plus I can write down minus 2, minus 4 I can write down minus 1 raised to 1 into 2 square is equal to minus 1 raised to 1 into 1 plus 2. Third line, which I can write down 1 plus minus 1 raised to 1 2 square plus minus 1 raised to 2 into 3 square. I can write down minus 1 raised to 2 into 1 plus 2 plus 3, and because 1 plus 2 plus 3 can be written as minus 1 raised to 2, and minus 1 raised to 2 is equal to 1 itself. And the fourth line, 1 plus minus 1 raised to 1 2 square plus minus 1 raised to 2 into 3 square plus minus 1 raised to 3 into 4 square, which I can write down minus 1 raised to 3 into 1 plus 2 plus 3 plus 4, which is clearly a certain pattern which you can see from this rewriting the above table in this format, and from this pattern, okay, one can guess the general law. Minus 1 raised to 0 into 1 plus minus 1 raised to 1 into 2 square, that is 4, and plus minus 1 raised to 2 into 3 square plus minus 1 raised to 3 into 4 square plus etc. I can write down minus 1 raised to n minus 1 n square, because in this first one 0, second one 1, third one 2, fourth one 3, so on and so forth. The nth one is n minus 1, and this I can write down minus 1 raised to n minus 1 into 1 plus 2 plus 3 plus etc. plus n, and that is equal to, which I can write down, minus 1 raised to n minus 1, 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 by 2. And thus you can see, therefore, the general, therefore, the nth term in the left hand side is minus 1 raised to n minus 1 into n square, and the right hand side now let us prove this general law. Right hand side is minus 1 raised to n minus 1 into n plus 1 by 2. Now let us prove this general law. Now let us prove this general law. What is that general law? That is minus 1 raised to 0 into n plus minus 1 raised to 1 into 2 square plus minus 1 into 2 into 3 square plus so on so forth plus minus 1 raised to n minus 1 into n square is equal to minus 1 raised to n minus 1 into now which I can write down as here n into n plus 1 by 2, and this is what I can write down is here as the general law is this one. We can write down this general law and we can prove this general law as we can prove this general law by induction on n. We can prove this general law by induction on n. For n is equal to 1, which you can see here, minus 1 raised to 0 into 1 is equal to minus, that is 1 itself, that which you can write down minus 1 into 0 into 1 into 2 by 2 is, so the result is true for n is equal to 1. For n is equal to 2, minus 1 raised to 0 into 1 plus minus 1 raised to 1 into 2 square equal to minus 1 raised to 1 into 2 into 3 by 2, and now we can cancel this, and that is equal to 3. Assume that the result is true for, and hence the result is true for n is equal to 1 and n is equal to 2. Assume that the result is true for n. Now let us consider the statement for n. I mean, now we can verify the law for n plus 1. Now we can verify the general law for n plus 1. Now that is, consider 1 minus 4 plus 9 minus 16 plus so on so forth plus minus 1 raised to n minus 1 n square plus minus 1 raised to n into n plus 1 whole square, and that equal to, now you can see for this one, for this, by assumption, by induction hypothesis, that is minus 1 raised to n minus 1 into n plus 1 by 2 plus minus 1 raised to n into n plus 1 whole square. N plus 1 whole square. This is by inductive hypothesis. Inductive hypothesis. Now this can be written as minus 1 raised to n minus 1 into n plus 1 I can take common, and that equal to, what is left out here, n by 2 plus minus 1 raised to n minus 1, which we have taken outside, that is a minus 1 raised to 1 into n plus 1 we have taken outside, that is what is left out in the bracket is minus 1 raised to n plus 1, that is minus 1 raised to n minus 1 into n plus 1 into n plus 1 is equal to, into bracket n by 2 minus n minus 1, and that equal to minus 1 raised to n minus 1 into n plus 1 bracket n minus 2n minus 2 divided by 2, which you can write down like this, and that equal to minus 1 raised to n minus 1 n plus 1 into bracket minus n left out and minus 2 is there and divided by 2, and this I can write down minus 1 raised to n minus 1 n plus 1 into minus 1 raised to 1 into n plus 2 by 2, because minus 1, which you can write down minus outside the bracket, so that you can write down minus 1 it can be written as minus 1 raised to 1. Now multiply with minus 1 raised to n minus 1 and minus 1 raised to n 1, that is minus n raised to n into n plus 1 into n plus 2 divided by 2, and therefore the result is true for n plus 1, and hence for all n. And this is what we wanted to prove, and we have established the general law with the given pattern given in the table.